Hey guys, this is the second half of the video to go through the solutions and explain the little worksheet that I've got for you from section 1.3. Okay, the second part gives you some problems from the part of 1.3 where we solve quadratics using the quadratic formula, and then some word problems where we are dealing with the Pythagorean theorem. Okay, so let's get started here. I think your first question there in this part of it asks you for the quadratic formula itself. So what you should have there is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, now the a, b, and c there come from the general form of the quadratic equation, which looks like this. Okay, with your a, b, and c being those coefficients and that constant. All right, if you're using the quadratic formula, all you have to do is plug the a, b, and c values in and then simplify it. You'll start inside underneath the square root. You'll do that part first and simplify it, and then continue on from there, finally reducing the fraction at the end. If it happens to be an imaginary number that you get, then you will want to split that into two fractions as well, just like we did when we were doing the division of complex numbers. Okay? Now, the second question under there asks about what the discriminant is and what it can tell you. The discriminant is the part that's underneath that radical up there, the b squared minus 4ac. And if b squared minus 4ac turns out to be less than 0, your solutions will be imaginary. If you have it greater than or equal to 0, then there will be real solutions, okay? So that's what you can find out by looking at the discriminant. It's not something you have to examine, but you can kind of know what to expect once you find, because you got to calculate it anyway. So once you figure out what this is as you're going through, you will know what type of solutions you've got, okay? All right, so let's take a look at the first problem it asks you to work. We want to solve this particular equation using the quadratic formula. And what I like to do a lot of times is come off to the side and just go ahead and write down my A, B, and C, just so I've got it sitting in front of me, and I don't have to go back and forth looking at the equation to find it. All right, so now we plug those in. X is equal to negative b. So b is already negative. It's a negative 10. So I'm just going to change the sign there and make that positive 10 plus or minus the square root of b squared. Negative 10 squared is 100 minus 4 times a times c, 4 times 3 times 1, you can go ahead and do that calculation if you want to as you're writing it down, over 2 times a, so we're going to have a 6 in the bottom. Okay, so let's work on that a little bit. 10 plus or minus the square root of 100 minus 12 over 6. Well, I can tell from the discriminant that this is going to be a real number because 100 minus 12 is not going to be negative, okay? So let's see, we get 10 plus or minus the square root, and if I subtract 12 from 100, I'm going to get 88. So I do have a little perfect square factor that I can take out of that, and we still got 6 in the bottom. So I'm going to have 10 plus or minus, and 88 is 4 times 22. 22 doesn't have any perfect square factors, so that's as far as we can go with that. If I go ahead and take the square root of the 4, we can bring the 2 on out. And you'll notice that the 10, the 2, and the 6 are all divisible by 2. If you want to, you can split it up into 2 pieces and then reduce it like that. That may be a little easier for you to do. And if it is, that's fine. Let me see if I've got enough room. Oh, just barely. I can move that part a little bit farther down. Let's see if I can. Yep. Okay, so 5 over 3 plus or minus square root of 22 over 6 is what we get for that. Okay, so there you go. If you hear something in the background, that is the Ellen Show, which is on in my den. My daughter's sick today, so she's home from school and she's watching that really loud. So you may hear that in the other room. Forgive me, please, for that. All right. So anyway, for this one, here's our new equation. One great thing about quadratic formula is that you can use it in pretty much any circumstances. A, B, and C can be negative. They can be positive. They can be fractions, decimals, whatever. This works out pretty well regardless, okay? So we've got a new set here. X is going to be equal to negative b plus or minus the square root of b squared minus 4 times negative 4 times negative 7 over 2a, so negative 8 on the bottom. So negative 2 plus or minus, the 2 squared was 4. And then let's see, we've got 16 times 7. That's going to be negative 112 over negative 8. Scoot up a little bit more. X is equal to negative 2 plus or minus the square root, and if we subtract those, that's going to give me a negative 108, which I believe will give us a perfect square factor. All right, 108 has a factor of 36. So we've got negative 2 plus or minus the square root of negative 36 times 3 over negative 8. I can go ahead and take the 6 and the I out as well there from underneath that square root. So plus or minus 6i on the square root of 3 over negative 8. And again, we can reduce. We will go ahead and split this one up too. So negative 2 divided by negative 8 is going to give me a 1/4. And then it's plus or minus positive 6 over negative 8. So we get a negative, which really will get absorbed in the plus or minus anyway, so we really don't need that negative. Because you'll still wind up with either a plus or a minus, even if you've got a negative attached to that. 3i on the square root of 3 over 4. That's what we get there. All right, so there's your answer to that one. And that's how you use the quadratic formula. All right, now, the... let's see. Let me make sure I know next slide. Okay. I've got my two Pythagorean theorem problems split up into two different pages. So here's our Pythagorean theorem. First problem we're going to use Pythagorean theorem on. Pythagorean theorem is a squared plus b squared equals c squared, where a, b, and c are the sides of a right triangle. C is your hypotenuse, and A and B are your two legs of the triangle. C always has to be the longest side. That's the hypotenuse, okay? So we use this little formula to put together the information that we know about the three sides of the triangle to solve for whichever side we don't know. And for our first one, we've just got a little triangle sitting here. I know the hypotenuse, and then I know something about the two legs. I know the relationship between the two, okay? One's 3x, one's 5x. So I can go ahead and plug those things in. We'll let the 3x be A. 5x will be B, because those are the two legs. And then the 10 is our C, so that's just going to be 10 squared. I'll go ahead and put that down as 100. All right, we can work on that a little bit. If we square 3x, you got to square both parts. So you get a 9x squared. Again, square both parts here. 25x squared equals 100. So if I add those two together, that's going to give me 34x squared is equal to 100. So x squared is equal to 100 divided by 34. I'm going to go ahead and get a decimal approximation for that. Take your calculator and just go ahead and put 100 over 34 in it, and then take the square root of that. And if we put that in the calculator, we get approximately, to one decimal place, 1.7. Okay, and I don't have any units on this one, so if the problem tells you to round to a different place besides the nearest tenth, just be sure you round to that specified place. Okay? All right, let's try another one. This one's very simple. The only difference is we have to set the little triangle up ourselves here. I don't remember the reading of the problem exactly, but it said something to the effect of you got a TV. It's a 60-inch television. The ratio of the length to the width is 16:9, and you want to find out what the height and the width are if the size of the TV, which is the diagonal of the rectangle, is 60. Okay, so first of all, diagonal is the measurement between two opposite corners, so that's our 60 inches. We'll just take this little right triangle right here to build it. 16:9 is the length to the width. That means for every height. For every 9 inches high, it's going to be 16 inches long, okay? So we express that as 9x and 16x. You set this up the same way as the last one. 9x will be our A plus 16x for B. And then if I square 60, we get 3,600. 9 squared is 81. 16 squared is 256. All right, scoot that up just a bit. And when I combine these two, I'm going to get 25, 30, 337. X squared is equal to 3,600. So what we'll do now is we'll do the division. And then just like before, we will do square root 3,600. We're really using the square root property to finish this one off, but you don't need the plus or minuses because since we're talking about a physical object with this triangle and rectangle, you don't need the negative. You're not going to have a negative value for x for either one of these. Okay, calculator's telling me that that's 3.3 approximately. And what we'll do for this one, I believe it asked for both sides, so we'll go ahead and plug that value in for both. So the height will be 9 times 3.3, which is 29.7. And then the length is going to be 16 times 3.3, which is 52.8. So that gives us the height and the length right there. And I don't remember, I'm sure it was in inches. Yeah, 60 inches. So those two are going to be in inches as well. Okay, and that should get you through the worksheet. If you have any questions, let me know.